So, you've got a free weekend, a garage, and a burning desire to dabble in a little antimatter creation. Maybe you saw it in a sci-fi movie. Maybe you just really want to bend the laws of physics before lunch. Either way, let's talk about what happens if you try to create antimatter in your garage. First off, spoiler alert, you're probably not going to succeed. But the reasons why are absolutely fascinating. Let's start with what antimatter actually is. Antimatter is, quite literally, the opposite of normal matter. For every particle that makes up your body, your sandwich, and your car keys, there's an opposite version, same mass, opposite charge. So instead of a negatively charged electron, you get a positron, which is positively charged. Instead of a proton, you get an antiproton. Combine those, and in theory, you get antiatoms. Now, the big thing to know here is this: when matter and antimatter meet, they annihilate each other. Instantly. Poof. And in that annihilation, they release energy. A lot of energy. A gram of antimatter, reacting with a gram of matter, releases the same amount of energy as the Hiroshima bomb. Yes, just 1 gram. So back to your garage. Let's say you're trying to build an antimatter generator. Maybe you've cobbled together a few magnets, some high-voltage equipment, a YouTube tutorial, and a can-do attitude. What happens? Well, not much, unless your garage happens to be a billion-dollar particle physics lab. See, antimatter is ridiculously hard to make. The most advanced particle accelerators in the world, like CERN's Large Hadron Collider, can create tiny amounts of antimatter, like a few atoms at a time. And it takes an enormous amount of energy to do even that. In fact, producing just 1 milligram of positrons would take about 25 million kilowatt-hours of energy. That's more electricity than your entire neighborhood uses in a year. For 1 milligram. So, unless your garage is secretly a nuclear-grade facility with superconducting magnets and a cryogenic cooling system, you're probably not whipping up antimatter anytime soon. But let's say, somehow, you pull it off. You create, like, a single positron. Congratulations, you've made history. Now what? Well, the problem is keeping it. Antimatter doesn't play well with, well, anything. The moment your shiny new positron touches regular matter, like air, or the wall of your containment device, or you, it annihilates. Gone. Energy released. If you want to store antimatter, you need a vacuum chamber and a set of powerful magnetic traps called a penning trap, to keep it suspended and isolated from all contact. That setup? Not exactly shelf-stable next to your lawnmower. Let's bust some myths while we're here. Myth number 1, antimatter is the key to free energy. Nope. Creating antimatter takes more energy than you get back from annihilating it. It's not a battery, it's more like an energy black hole. Myth number 2, antimatter is unstable and might explode spontaneously. False. Antimatter isn't unstable by itself. It's actually very well behaved, right up until it meets matter. Then it goes full Michael Bay. And myth number 3, governments are hiding antimatter weapons. While that sounds awesome in a spy thriller kind of way, it's just not practical. It takes enormous effort and money to produce the tiniest amounts of antimatter. Making enough for a weapon would require a space station-sized facility and a few centuries. So, no, your neighbor isn't secretly building an antimatter bomb. Hopefully. Now, why do scientists bother with it at all? Because antimatter is one of the biggest mysteries in physics. According to the Big Bang Theory, the universe should have created equal parts matter and antimatter. But clearly, we got stuck with all the matter, lucky us. So where did the antimatter go? Understanding it might unlock answers about the origins of the universe, the nature of time, and maybe even lead to futuristic propulsion systems for deep space travel. So, what happens if you try to create antimatter in your garage? Best case scenario, nothing. Worst case scenario, you accidentally make a positron, it annihilates with an electron, and you release enough energy to maybe warm up a cup of tea, if it weren't so instantly absorbed by your garage walls. The real danger isn't a boom, it's the delusion that you're going to outscience the entire global physics community with some duct tape and an old microwave. But hey, thinking about antimatter is awesome. It pushes us to question how the universe works. It inspires science fiction and real-life science alike. So don't give up your curiosity, just maybe don't try to replicate particle collisions next to your lawn equipment. So next time you hear antimatter, don't think garage experiment. Think cutting-edge research, cosmic mysteries, and the wild, brilliant edge of what humans are just beginning to understand. Stay curious. Stay safe. And maybe leave the antimatter to the professionals.